Hi guys, look at this question. The question is 3 to the power x plus 3 to the power y plus 3 to the power z is equals to 837, and we have to find the values of x, y and z, and it is given that x and y and z they all belong to integers. Now let's suppose that x is greater than or equal to y and y is greater than and equal to z, and they belong to integers as it is given. Now, according to our assumption, first of all, we are going to take out 3 to the power z common. If we take 3 to the power z common, it means that the power of 3 will reduce by z in every term, right? So, taking out 3 to the power z common, so you have here 3 to the power x minus z. This power is reduced here, and here it is 3 to the power y minus z plus 1 is equals to 837. Now let's find the factors of 837. First of all, dividing it by 3, so you get here 2, 7, and here you get 9. Further dividing by 3, you get here 9 and 3. Further it is divisible by 3, this is 31. So we can write this expression as plus 3 to the power y minus z plus 1 is equals to, this is 3 to the power 3 into 31. Now look at these two, these are the two possibilities. So we have 3 to the power z, we can equate this 3 to the power z to the 3 to the power 3, and this 3 to the power x minus z plus 3 to the power y minus z plus 1 is equals to 31. Now according to this, we have same basis, so we have the same exponents as well, so we can write z is equals to 3. So this is the first value that we have evaluated till now. Now according to our second equation, we can just move this one on the right hand side. 3 to the power x minus z plus 3 to the power y minus z is equals to 31 minus 1. Further you can write this as 3 to the power x minus z plus 3 to the power y minus z is equals to 30. Now dealing with this equation, if we take out 3 to the power y minus z common, so we are left with 3 to the power x minus z, and this power gets reduced from the power of 3 plus 1 is equals to 30. Further you can write this as 3 to the power y minus z into 3 to the power, this is x minus z, open the bracket, minus y plus z plus 1 is equals to, now this 30 can be written as 3 into 10. Further you can write it as 3 to the power y minus z into 3 to the power, now this z and this z gets cancelled, so 3 to the power x minus y plus 1 is equals to 3 into 10. Since here we have the base 3 and here we have the base 3, so we can equate them, that is 3 to the power y minus z is equals to 3 and 3 to the power x minus y plus 1 is equals to 10, right? So we don't have any power here, so this is the power 1, y minus z is equals to 1. Now as we evaluated earlier that z has a value 3. Putting this value in this equation, y minus 3 is equals to 1. Just move this 3 on the right hand side, so we have 1 plus 3, or we have y is equals to 4. So this is our second value, right? Now working on this equation, just move this 1 on the right hand side, so this is 3 to the power x minus y is equals to 9. Further you can write this 9 as a power of 3. Again we have same basis, so we can just equate their exponents. So since here we calculated y has a value 4. So putting this value, or you can say x is equals to 2 plus 4. So x is equals to 6. Now the solutions of x, comma y, comma z is equals to x is 6, y is 4 and z is 3. Now this is the solution in case when we suppose that x is greater than y is greater than z. But it's not compulsory that they are greater than each other. In fact, the values can interchange as well. So there are 6 total possible solutions of this equation. So when x is equals to 6, y can be 3 and z can be 4. Next, if x is equals to 4, then y can be 6 and z is equals to 3. And if x is equals to 4, y can be 3 and z is equals to 6. And the fifth possibility is that if x is equals to 3, then y can be 6 and z can be 4. And the last possibility is that if x is equals to 3, then y can be 4 and z is equals to 6. So these are the 6 possible solutions of this question. I hope you understand it, and if you like it, kindly subscribe my channel.